Hello, and welcome back to Precalculus. Today we're going to be talking about solving equations, specifically about linear equations and absolute value equations. There are many other types of equations, and we'll spend the next couple of days looking at those. But today, we're just focusing on these two. So grab those notes, put away the distractions, and here we go. First, I want to talk about the difference between an equation and expression. So far, everything we've dealt with have been expressions. An expression is a collection of numbers, variables, and other symbols, like exponents or radicals. And you know what? So is an equation. In fact, on paper, at first, when you're looking at them, they look almost identical, but they've got one big, huge difference. Equations have to have an equal sign, otherwise they're not an equation. And expressions can't have equal signs because then they wouldn't be an expression. So that's your big major difference. An equation has an equal sign, an expression does not. The directions for an expression are going to say something like simplify, something along those lines. Your equation is going to say solve, find a solution, because we're looking for something that we can replace the variables with and actually have a true statement. As soon as we have that equal sign, this thing is turned into a sentence, a mathematical sentence, and we have to try and make it true. That's what a solution does. It makes the sentence true. Expressions are neither true nor false. They're just a collection of numbers and variables and other random symbols. And so those ones we can simplify, but we can't say what makes it true or false because it's not a sentence. It's the beginning half of a thought, but it's not the complete thought. When we're dealing with simplifying, we follow our standard order of operations, you sometimes refer to as PEMDAS, or please excuse my dear Aunt Sally, or something along those lines. I don't like those quite as much because it gets a little weird. Parentheses, you can also think of these as grouping symbols. So yes, parentheses are part of that, but you can also have square brackets. And sometimes you even can see the infamous curly bracket used as a grouping symbol. We use them for something else in this class, so I'm going to erase that part. Then you deal with your exponents. Multiplication and division are dealt with at the same time from left to right. Addition and subtraction are dealt with at the same time, again, from left to right, just like how we read a book. The order of operations, in quotation marks, because it's not exactly an order of operations, for solving equations goes something like simplify the expression on each side of the equation, using regular order of operations, move like terms to the same side of the equation using addition and subtraction. And then once you've got your all of the terms with your variable on the one side, you want to isolate that variable further using multiplication and or division. Whenever I'm trying to solve for X or Y or whatever it is that I'm trying to solve for, I pretend like it is an antisocial, introverted, whatever person that does not want anyone anywhere around them at all and wants all of that other nonsense on the other side of the equation so they don't have to deal with it. And so that's kind of the objective when we're solving for a particular equation. Alrighty, solving linear equations. We're not going to start off with the easy ones because this is pre-calc. You've already done those in Algebra 1, Algebra 2, maybe some in geometry. Let's start with more interesting examples than y equals mx plus b. So, diving right in, we're going to do some distribution. We want to get rid of grouping symbols. That's usually our first objective if we can. So this becomes positive 64, positive 8k. And then we're going to continue simplifying that one side of the equation, 65 plus 8k. Sometimes around in here, I get asked, Miss Norton, you show a lot of work. Are you expecting us to show all of those steps and all of that work? Not really. I show more steps than is, I think, absolutely needful because sometimes it's been a while since you've done any math, right? And I did not need to do that. And sometimes, oh, nope, I did, but kind of going the other way. So, sorry, I can't talk and subtract at the same time, apparently. Hang on, 5 minus 26, negative 26 equals 13k. It's been a while sometimes since you've done any math, and sometimes people need to see all of the steps drawn out in careful detail to remember, oh, right, that's how this works. I remember now, and then they can just go from there and everything's all fine and hunky-dory. Both of those are divisible by 3, so I think we'll just go ahead and do distribution. Ba-doop, ba-doop. Don't forget the negative is also needing to get distributed. That's really a 5. I know it looks like an S. I'm working on my font. 4 divided by 3 times 9w minus 4/3 times 51 equals 7w minus 68 plus 5w. 9 divided by 3 would be 3. 3 times 4 is 12w. Minus 51 divided by 3, I think that's 17. Yeah, that's 17. 17 times 4, 28, 68. So then this would equal, hold up, Michael shenanigans, 12w minus 68 equals 12w minus 68. If I try and move things to the same side of the equation here, shenanigans. 0 equals 0. So technically I could have stopped back up here as soon as I realized that I had the same thing on both sides of the equations. It does not matter what value I put in there for w, it's always going to be true. I can plug in 2. 2 times 12 times 2 minus 68 is going to equal negative 68 plus 12 times 2. I could put in 100 bazillion gazillion and it would still work. I could put in pi. I could put in negative 53.78 and it would still always be true. This is called a tautology. And when we're talking about solutions, we would say something like all real numbers. But we're mathematicians and we don't like to write more than we absolutely have to. So there's a symbol for that. It's basically a capital R, but with an extra little piece to his backbone. So it's a nice thick backbone on that R, and that's all real numbers. Floop. And you can write all real numbers if you don't want to write the goofy R. That's fine. I just personally don't like to write more than I have to. Alrighty, here we go. Last one. This becomes 2x plus 11 equals 3/2 times 4/3 x plus 3/2 times 12. I'm going to put that in parentheses. Just remember that that's a multiplication. 2x plus 11 equals 2x plus 18 plus 7. Uh-oh. This looks like more shenanigans. All right. Yep, we've got shenanigans. 11 equals 25. Does 11 equal 25? No. 11 does not equal 25. There's no way that 11 equals 25. This is called a contradiction. This guy over here is called it, the middle guy is called a tautology because he's always true. This guy's called a contradiction. He's never true. There is no value for x that I can plug into this thing that will magically make 11 and 25 the same thing. It just, no, that doesn't work. So you can either write no solution, and again, there's a shortcut for that. You draw a circle and then a diagonal line through it. It's very important that it's a diagonal line. This is actually a Greek letter. And we'll talk about him later, give it a few months. So you don't want to do that because then that looks like you're writing a variable and like, what does that mean? So it's very important that it's a circle, diagonal line, like the no smoking sign came from math. Woot! So no solution, there is no answer. So when you're solving linear equations, you have 3 possible types of things that you can run into. You can run into a tautology where everything is true, so all real numbers. A contradiction where nothing is true. And you just have no solution, or where you have one real solution. And as always with the equations, you can always know for sure that you have the right answer by going back up here and plugging it back into the original equation. It's very important when you're checking solutions to always go back to the original equation because you might have made a mistake on that first line. So always go back up to the original. I should be a good example and model checking solutions. Okay, minus 5 times negative 10. So that's 39. I multiply that in my head. Plus 10. So that's 49 on the one side. Boop. 1 minus 8 times negative 8 minus 2. 1 minus 8. So that would become negative... Oh, minus negative 2. Hang on, something wasn't working. Floop. So negative 8 plus 2. So that becomes 1 minus 8. Again, showing out all of the details, all of the work. It is useful. Those two things are equal. So we have checked our work and confirmed, yes, that is the solution. Okay, enough about linear equations. They're kind of boring. We want to talk about, literal equations, and then we'll get to the fun ones, the absolute value ones. So a literal equation is just kind of this curriculum's speak for, you're taking a formula and you're solving for a specific variable. And basically just treat all of, sometimes we get overwhelmed by all of the other letters that are going, just ignore them. Ignore them. They don't matter. The only thing that matters is the variable that you're going for. So in our first example, we are going for J. And J, let's see where, there's only one J, so that's nice. He's in a denominator. I don't like denominators. So one of the things that we do when we have denominators and we don't really want denominators is we just multiply everything by the denominator so that it cancels out over here. That gives me 8h equals 6k times 3j. And now I don't have a denominator anymore. Yay! Life is so much easier without denominators. 18jk. But I want the j by itself, so I'm going to divide by 18. So that's going to give me, those are both even, so that becomes 4 over 9h equals jk. And I want to get rid of the k. So we have 4h over 9k, and that is going to give me j. Did I need to do all of those steps? Maybe, maybe not, but they're all there. These ones, you can't really go back and check your work. I mean, I guess you could. If you plug this back into j, you would end up, what you're hoping will happen is you get a tautology, one of those cases where everything is true because everything just cancels out. We're not going to do that. Next one, I want to get b1 by itself. Again, I see a fraction. So first thing I'm going to do equals 1/2 h b1 plus b2 is we're going to multiply this side by 2 and this side by 2 so that the 2's cancel. Because why deal with fractions if you don't have to? b1 plus b2. So at this point, there's a couple different strategies that people will use. One thing is to go ahead and do the distribution so that you get rid of the parentheses, which is perfectly fine, and then move the term over to the other side and then do some more subtraction and all of that wonderful fun stuff. Perfectly valid. I'm not going to do that because that's going to add an extra step into my stuff. I'm just going to divide by h, because h divided by h is just going to make that go away. So I have 2a over h. Try to make that look more like he and less like an n. And then this is b1 plus b2. I'm trying to get b1 by itself. So I'm just going to subtract b2. So 2a over h minus b sub 2 is equal to b sub 1. Bada bing, bada boom, moving right along. All right, solving absolute value equations. Wahaha, the real, actual, interesting thing that we're talking about in this particular video. So there's a process. There's always a process. Trust the process. We're going to isolate the absolute value. Then we're going to create two cases, and then we're going to solve each case individually. Multiple solutions happen quite frequently. Absolute value equations typically have two answers. And what we're going to do is we're going to make curly brackets, and we're going to put the two answers inside the curly bracket with a comma in between them. If you are a typer type person, you can find the curly brackets. They're right above the enter key. The base model looks like this, but then you've got the little curly brackets up on top. For me, when I first met these guys, I could not draw them. No, this is nonsense. I can't draw these, but I'm writing and I'm taking my notes and I'm writing for my homework, so I have to figure out how to do this. So for some reason, going like this was easier for me than going like that. So what I had to do in my head is this one kind of looks like a 3, right? But instead of making the butt go this way or the inside part go that way, we're just going to invert it and shove it out so that it's going this way. That's how I draw them. That's me. Everybody's got their own thing that they kind of go through in their head for drawing these guys. I don't know why that's what my mental image had to do, but it is. This one, the first one was always way easier for me to draw. I don't know why. It's kind of like a parenthesis, but just with a little schloop sticking out. But for the other one, I couldn't think of parentheses. I had to think of it's a 3 with its guts pulled out. I don't know. So we're looking for an absolute. One note, an absolute value cannot equal a negative number. If you at any time end up with something like the absolute value of x minus 2 is equal to negative 3, stop. No solution. None. You cannot have an absolute value equal to a negative number. Absolute values are distances. The absolute value of x minus 2 is equal to positive 3 means that the expression x minus 2 is 3 units away from 0. So the absolute value is asking how far away is the stuff inside away from 0. That's what absolute value is asking. So it has to be a positive number because it's asking for a distance, and distances cannot be negative. All right, let's get into the fun stuff. All right, first things up, we have to isolate the absolute value. So let's gonna start by adding the 9 over to the other side. So that gives me negative 34 is equal to 2, absolute value 6 plus 8k. And then I'm going to divide by 2, and that gives me negative 17 is equal to absolute value 6 plus 8k. Basically what I'm doing is I'm treating the absolute value as if it's one giant variable that I'm trying to isolate and get by itself. Now that we've gotten it by itself, wait a second. Hold up. We're done. No solution. It equals a negative number. We can't have it equal a negative number. That's not allowed. Okay, I mean, that's all right. I forgot that that's what I did for the first example. Moving on. Minus 1, negative 10, absolute value 9r plus 3 equals negative 30, divide by negative 10, divide by negative 10, absolute value 9r plus 3 equals positive 3. Ah, that's a positive number. Check. We can move on with life. Okay. So what we want to do is we want to split this into two equations. We want 9r plus 3 equals 3, and we want 9r plus 3 equals negative 3. This is how I split it. I take the thing over here and I make a positive 1 and a negative 1. There are some students that I've met that this is not how they do this. They're like, no, that's weird. And what they do is they take the stuff inside here and they make a positive 1 and a negative 1. So their equations would look like 9r plus 3 equals 3, and then negative 9r plus 3 equals 3. Perfectly fine. These are both equally valid methods for approaching these problems. It doesn't matter which one you pick. Just be consistent. If you make both of these negative, like this one negative and that one negative, you're basically going to end up with your original equation and stuff just isn't going to go nicely. So I don't care which one you do. I'm going to do the one where I change the smaller side to the negative because that's less work. For me equals 0, r is equal to 0, minus 3, 9, r is equal to negative 6, r equals negative 6 over 9, which is also known as negative 2/3. So I'm going to make my curly bracket. We usually list solutions from least to greatest along the number line. So we would say negative 2/3, comma 0. And that's it. And that's basically what we're doing. One of these does something weird. I don't remember which one. Oh, right. Check your answer. Always go back and check your answer because an absolute value cannot equal a negative number. So this is actually one of the times where, no, legit, go back and check your answer. So 1 minus 10 times the absolute value of 9 times 0 plus 3. That would become 1 minus 10 times the absolute value of 3. 1 minus 30, negative 29. Okay, that one checks out. Bloop. And then 1 minus 10 absolute value 9 times negative 2/3 plus 3. 1 minus 10, let's see, 3 times 3, 9 divided by 3 is 3. 3 times negative 2 is negative 6 plus 3. 1 minus 10, negative 3. That becomes 1 minus 10 times 3, which is 1 minus 30, which is negative 29. Okay, they both check. We're good. Whew. All right. Moving right along. This is already simplified down, so we're just going to go ahead and split it. And this one, it doesn't matter which way you split it. They're both equally irritating. 3a minus 10, 5a plus 8 equals negative 3a minus 10. So 5a plus 8 equals negative 3a plus 10. Moving that over here, that gives me 8a plus equals 2, right? If I subtract the 8 over there, yeah. So a is equal to a fourth. And then bringing that over here, this would be 2a equals negative 18, or a equals negative 9. So negative 9 comma 1/4, we think, but we have to check our answers. So 5 times negative 9 plus 8 is negative 45 plus 8. Negative 45 plus 8 is negative 37. So this is all absolute value, so that would turn into a positive 37. 3 times negative 9 minus 10. Hold up. 3 times negative 9 is negative 27 minus 10, which is negative 37. Is negative 37 the same thing as positive 37? No. This is an absolute value equals a negative number? Nope. So this guy actually doesn't work. Let's try 1/4. So 5 times a fourth plus 8. That looks irritating. Let's try the other one and see if we run into some kind of issue. 3/4 minus 10 is negative 9 1/4. That negative, that one doesn't work either, because an absolute value cannot equal a negative number. So this guy's actually no solution. Huh, so cool. All right, not going to finish up the last one. It does work. You do end up with a solution or two for that one. So, some people think, oh, maybe the reason was because there was a variable on the other side. That means there's no solution. That's not the pattern. Don't go there. There are solutions for this guy. If you work him out, we'll actually have a solution. So, one main big thing with when you're solving equations is that if there's any interesting thing in the equation, like an absolute value or a square / cube root, treat that big huge thing like it's a big huge variable and get that interesting thing by itself first, then undo the interesting thing, and then work on getting the variables by itself. That's kind of the process that you go through with the weirdish type of equations. Our next video, we're going to be solving equations, of course, but we're going to kick it up a notch and we're going to talk about quadratic equations. Whew, quadratic equations, those are always so much fun. Don't forget to go back through your notes, make sure everything makes sense to you, and then also fill out that video reflection form. Happy mathing!